Hi Shane, how are you?
Good. How are you?
Good. So I didn't end up taking the MCAT this weekend, and my mom wants me to take it today after our lesson
Okay.
for the rest of this evening, and then I'm gonna do the way that I did the last one in parts. I don't know if you can even do that for AMC though, but like if I need to pause it
Just
before psych and social or something, cause it'll get late, and then take the next one tomorrow morning.
I mean, I would say that that's not ideal because that's not like testing.
Test.
So, yeah, is there any way that you can take it all in one sitting?
Yeah, I mean, I'm definitely gonna do it so we finish at like 6 and I'll do it then.
Um, like the entire test?
Well, yeah, said I have to do it today. So
Yeah, yeah. But yeah, I guess that's why we wanted you to take it on, over the
weekend, I know. I just I was feeling really unconfident with like physics. I don't know. I just wanted more time to review. And I guess I know that that's not a good idea because I'm never gonna feel completely ready, so it's just better to start taking the exams than spend time doing that. But if we could do practice today, like the AMC Q bank, I still have some left there. Like if we could spend today doing that, and then I'm gonna take the test and then we can review it
the
over the week.
section bank you're saying?
Yeah.
Okay.
Or do you want me to work on that on my own?
I mean, yeah, we can go over some stuff from that. But yeah, what stuff in physics do you not feel the most comfortable with?
I mean, just formulas in general. I've really been trying to push out remembering every single formula and
Uh-huh.
um, getting doing practice and getting stuck, and then I review which formula to use, how best to solve that problem.
Yeah.
So it's just,
Did you,
nonstop.
yeah. Have you been doing the Anki stuff to remember the formulas?
I did Anki. I made my own flashcards on paper. I find throughout college that I've worked better off of a paper studying situation. Like computer just doesn't work great for me, so
Um,
I've tried that.
so yeah, the thing with the paper cards is that there's no the benefit of Anki is that depending on how well you know the card, it'll adjust the frequency at which you'll see the card.
Yeah, I know.
You don't really get to do that with paper cards, so I think it'd be best if you just did the miles down equations deck. Because if you just do that, you'll have it down. But if you make more cards and things like that, it's kind of just more like busy work that won't help at the end. So I would say to definitely
Okay.
try to use Anki and to memorize formulas that way. Um, and what about the functional groups? How are you doing at that?
I feel like functional groups have gotten a lot better over this week. Over the weekend, I mean. I have a pretty good grasp of them, just off of the top of my head. I can draw a good amount.
Okay. So
I feel like I'm getting there. It's not where I want to be this close to test day. Do you know what I mean? Like,
yeah.
and then I realized I don't remember. I know we went over it, but I still don't remember all the amino acids.
Okay.
So there's just things over all the sections that I really feel like I need to review. And then psych and soc, I was going over the behavioral development groups, what from each category, 0 to 2 months, the different stages of development I went over this weekend. So I was doing I guess what you're saying, busy work, instead of taking the exam, but I
Yeah.
don't know.
I think not taking the exam was not a good idea. Because now you're gonna have to take it if you're taking it at 6 p.m., you're gonna end at maybe 11 p.m. or something like that. So uh so yeah, I think that that's not really the best. And then for the memorization of the formulas and amino acids and stuff, how are you approaching that? Because you can use Anki for that stuff as well.
I know I don't like the Anki deck for the amino acid stuff because I've noticed that the way that I have it written out like on my iPad and whatever else is like a very like obvious way, and on those I memorize it. But then if I see like an actual structure of the amino acid, I'm like not connecting the dots like quite the same way. So I was working on like making sure that I can visualize like which amino acid it is based on like a regular drawing and something that could appear on the MCAT versus like a hand drawn like, just structure.
Wait, what do you mean by that exactly?
Here, let me open my Notability and show you.
Oh, one sec. Okay,
Okay.
so
You see how it's like, sorry, my computer's freaking out.
yeah,
Do you see how these are like I don't know, just like super obvious. Like when I see these kinds of structures, I know the amino acids for the most part. But then like that's not how they really appear on the MCAT.
yeah. So you definitely want to be able, I mean, if you know the amino acids, it shouldn't matter like how they appear.
But I don't know like these completely. But it's like even when I like go through and I learn them and I like memorize them, it still isn't enough. Like because I'm memorizing them like this, and then I don't know, it just doesn't always translate well
Yeah,
for
so
me.
if you really knew the amino acid, it shouldn't matter like what format it is, but if you're dependent on just this type of format, like that's not how it'll look like on the test, you know?
Yeah, I know.
So I think you should continue with the Anki for it because that's how it'll actually look like on the test. So like, one of the big things here that I see is you're writing out like CH2 each time, which is like for instance like methionine, like that's just going to look like, the R group is just going to look like
S.
something like that, right? And you need to be able to see how you need to be able to draw things in this type of format without having to draw like the CH2 part and the S and then the CH3 because you're not going to see it like that. You know,
Mm-hmm.
like by convention, it's like the reason that we draw it like this is to save time. So you should be able to see this and write it like or recognize that it's like this.
Okay.
So yeah, I would say to definitely use Anki because there's really like no better way to just have things, enter into your, memory than Anki because it will make it so that like, well, first of all, it'll be shown in a way that will be shown on the MCAT because it won't be shown like this. But also you want to like be able to recognize it regardless of how they draw it.
Yeah.
So
Okay. Yeah.
they
All right.
definitely try sticking with Anki for that.
Okay. All right. Let me open um, which topic do you want to do today?
Oh, one sec.
Hmm?
Sorry, just making some coffee, but yeah, so you said that you felt uncomfortable with like the physics stuff. So what type of physics stuff?
I just feel like physics is such a like there's so much there. You didn't like the physics question pack, right?
Oh yeah, no. I guess we can go over stuff from the section bank, but if we talk about, because you said that, one of the main things that made you not want to take the test like over the weekend was that you didn't feel comfortable with the physics stuff. So, you know,
I just feel
tell me
like
like,
as we were going over the Jack Weston, there were like several topics that were bothering me. For example, like when we were doing the like electrical circuit one, that one I didn't understand, and then waves was a big thing.
all right, so
Um, what
some,
else? We did like the free fall problems, which like the free fall equation that I do know, but it's like figuring out what I have and like which equation to use because sometimes there's multiple like for each scenario. And then I
yeah,
kept trying to use like the acceleration due to gravity, and then we weren't talking about that. So, there's just like several things that were bothering me
all right, so
with physics.
let's look at some of that stuff.
Okay, all right, I'm opening to. Right. Oops.
So if you want, you can open up that Jack Weston content diagnostic again, and you can use that to show me the types of problems that um in physics that you're still not grasping.
I feel like all of these I wasn't great with. Like as much as it says that like
So
no, I feel like it's
you can
fine in conservation of power. We've done a lot of work in power stuff. So
yeah, you can go back, you can hit like the review all thing, and then we can go to like some of these problems. Or
okay, where's review? Oh,
oh just yeah. So yeah.
no, this is it. This is chem. I think this one is also chem, yeah. Like it doesn't separate it
Mhm.
in a helpful way.
Maybe around like yeah.
No, this is all.
Okay.
No, this I understood. We spoke about this. It's a ratio. Yeah.
So yeah, you're like in the physics question region now, so we can kind of like just use like previous next to look through these. But I would say probably go back to navigation and hit like let's try question 50. Um,
No, this one
go
is.
back. We can go back some more. Yep, keep going.
So you explained to me that this was just MGH is the equation that I use here.
Yeah, let's go back just so we can see like where the physics problems start, like the physics questions. So yeah, you can keep going back. All right, basically here. So like this is the end of the Gen Chem portion. And keep going. Keep going. Keep going. And yeah, this is where the physics starts. So like we can, as we look through these physics questions, we can see if, if any of these or which of these,
Well, I remember here the issue was like the kilometers per hour and then it's in seconds, so you have to like change this to meters per second, right? Like that was the first step of this problem.
so like let's think about like the big picture. So like what is this question like asking us?
Acceleration.
All right, and what's acceleration?
Isn't it distance over time or like velocity over time?
Which one?
Velocity. A equals V over T.
So
Yeah.
basically an acceleration is when you have a change in velocity, right?
Mm-hmm.
So basically we want to see what the change in velocity is here.
Mm-hmm.
So what's the initial velocity? What's the final velocity?
Okay. Um, Initial is 0
Good.
and final velocity is like the 360
Uh-huh.
kilometers.
Yep. So yeah, you would just have to convert that into meters per second, and then you would just do like change in velocity. So that value in meters per second.
36,000 meters
Um, so it'll
or
be
more.
60
360 that.
meters per
Yes.
hour. And then I would do in 1 hour, 3,600
6
seconds,
seconds.
right?
Oh, and then you get rid of a lot of that.
Yeah, we could even turn this into left add, right subtract, like that. Oops, yeah. And then the 3,600s cancel, right? And so you have
100
2 meters, yep. And then now that we
per
have
second.
change in velocity here, or rather, yeah, pretty much a change in velocity because this is the final velocity. And then change in velocity is v final minus v initial, or 1e2 meters. Oh yeah, per second. Per second,
over
0,
over time.
yep, over the 50 seconds.
Seconds.
This will be 1e2 meter
Over
per second, um, divided by
time. 1
50
over 50.
seconds. So 1 over,
So 20, it's
I could do
sorry, 2 meters
one,
squared.
2 over 5 E1. You get 0.1 E1,
The
which,
E is so confusing here. Why aren't we just making it into 100? Or that, yeah, 100.
oh, I mean, we could do it like that. Um, so 100 over 50, 5 goes into the 10 twice. So it's 2
2
meters per second,
meters per
right?
squared. Yeah.
So, yep.
So this equation I knew. Oh, still I wasn't sure, and this is like the easiest one. Okay, I mean friction. I when we were doing this, I knew that like normal force and friction are always opposite from each other, so it's just 40 minus 10.
Oh, well, so normal force is,
The direction on the plane that the object is traveling on normal force. I know I said it wrong, but the like the direction, the force of like the object is being moved with, and then friction goes in the opposite direction.
Yeah, so friction, air resistance, which is just another variation on friction, will always be in the direction opposite to the direction that it's moving,
Mhm.
right? And also friction, force of friction is going to be the coefficient of friction, which is this mu symbol,
Mhm.
times the normal force.
Yeah.
Right? So okay. Now they're telling us that the thrust from its engine is 40 newtons. So if I just drew a little block here, going in this direction with, I'll just write a force of 40 newtons, right? Right.
Mhm.
And then they're telling us that it experienced an air resistance
Up 10 newtons.
newtons. So I'm going to write FA 10 newtons. And now we just need to find the friction. So in which direction will that friction force be?
Against the normal force.
Well,
The
we didn't
force.
do any, we didn't write any normal force here.
Okay, so like F, it would be in the opposite direction, so the same as this, the air resistance.
All right, good. So I can draw another one here to be the force of friction. Now, how can we figure out what that force of friction would be?
Wouldn't air resistance act as the friction here?
Well, they're telling
Because
us that
friction,
both friction and air resistance, right? That friction and air resistance both act on the car. And so the FA here is for air resistance, 10 newtons. The F here is the force of the thrust moving the car forward, 40 newtons.
the friction is what we're calculating for.
Okay.
Between the ground and the car's tires. So if 40 and 10 is going the opposite direction, then you have to subtract 10 from 40, and then that would give you the friction.
So how do we know that though?
It's something to do with the fact that they're in opposite directions. That air resistance and friction are operating in the same direction right now.
Okay.
But it would be the same in any scenario, no?
I mean, yeah, it'll all the frictional force, the air resistance force will always be in the direction opposing its motion. But there's something that they are saying in this path in this question stem that lets us know that
Both act on the car in the direction which opposes its motion.
so yeah, there's something here that they're in the question stem that indicates to us that the net force is 0. And remember Newton's second law, it's the sum of all the forces, or F net, is equal to ma.
Mass times acceleration. Um, it's in Newton's second law, like an object in motion will stay in motion unless acted upon by something else.
First,
So if the car is traveling at a constant speed along a road,
okay.
like not that friction is negligible, but it's not enough to stop the car from moving. Like it's not braking or anything. So,
The Newton's second law is what I wrote here.
right.
The first law is when, yeah, if an object in constant motion will stay in constant motion unless acted upon by an outside force, and then an object at rest will stay at rest unless acted upon by an outside force. So what that means is, well, if something is at a constant speed, it will remain at that constant speed unless it's acted on by some net force that's not zero. So they're saying something here in this question stem that indicates to us that the net force is going to be zero. So
Opposes its motion.
so you can have like friction air resistant will always oppose the motion, but
Right.
but
But
what's
it's the constant speed, is it not? The fact that like it's traveling and that there's no change happening.
so constant speed means
Constant velocity.
which means what about acceleration?
Acceleration is like not happening, it's zero,
Yep,
which means that F net is zero.
exactly. That's why
I okay, so the sum of the forces has to be zero.
yes. So that's
So
why
then 40 in one direction and 10 and 30 in the opposite direction will come to be zero.
yeah.
I understand. Okay.
So that's only because
Not that we're just subtracting 40 and 10 because those are the two values given. It's the like we have to reach like F net of zero.
yeah, and that the only piece of information that we have that lets us know that F net is zero is them saying constant speed.
Okay.
Constant speed means zero acceleration, which means F net is equal to zero, which means that the sum of all these forces will be zero. And that's what makes that frictional force 30. But
Okay.
if it wasn't at constant speed, then we can't make
We
that.
can solve this.
Not from what they give us, no. I mean, if they told you that it's some speed of some sort that changes or it accelerates, we would need
Solve.
information. But
Okay.
but yeah. Okay. So how is this a
So
question?
we have work, we have distance, we're calculating force.
Uh-huh.
Is it's not work times distance, right? It's W equals F times D, so it's work divided by distance. So 10 divided by 2 is 5.
Good.
Yes. Okay. The weight is 1,000 newtons.
Okay. So this is
Work equals, right. You can't just use weight divided by distance.
so this is a topic called like simple machines.
Mm-hmm.
And what that does, a machine, what that does, by definition, is that it reduces the amount of like force that you must input to produce the same amount of work. So that means let's say we had some parcel here with 1,000 newtons, and if we lifted it up, this distance d of 1 meter to have it come up here, the work would be, what do you think?
If it's not on a ramp, you mean?
Correct.
But we don't know what the force is. Are we assuming?
So
Well, It
what
would be doing less work
so
or
um
more work because it's not on a ramp. It's harder to lift.
so just I'm just asking about if it's here on the ground and you lift it up to this distance here.
Uh-huh. Well, it's work divided by distance.
Well, what are you trying to
It's force.
well, let's find work first because
How?
well,
We don't have work or force. Like we only have distance.
uh-huh. So now remember that work and energy could be thought of as interchangeable.
Mm-hmm.
So if you took something that's on the ground and you lifted it up 1 meter, right? Tell me about what happens in terms of energy.
Um, it would have to be greater than the force of, well, now I'm thinking back to gravity. And but right, wouldn't it have to be greater than 10?
So
Because,
let's just think straight up in terms of there's something on the ground and and you pick it up and you put it up at a higher point from the ground. So that's going to
yeah,
mean huh?
right, but like I don't remember the energy equation.
So let's think first what type of energy. So like would you agree that if you take something from the ground and you lifted it up to a higher height that you would have some type of change in energy?
Yes, because
Okay.
energy would have to be applied in order for you to be able to lift it.
So yeah. So now let's think about what type of energy would it be if you simply took something and you put it up to a higher height? Like what type of energy can you think of, I guess, different types of energy?
For some reason, all I can think of right now is E photon
Hmm.
and Fe cell equation.
So okay. What else could exist? Like what other types of energy could exist? Like if you threw something out the window, right? That thing that you threw out the window will start to fall. And as it starts to fall, you know,
Oh, kinetic and potential energy?
uh-huh.
Okay.
And so if you threw something from the window, what type of it would have some type of potential energy. What type? Like, what's the thing that's bringing it down?
Gravity.
Okay.
Gravity potential energy, and that's like 10 meters per second.
Uh,
And then that's not the right unit.
so gravitational potential energy, right? If
Right.
if you're taking anything and you're changing its height, right? If you take something and you put it at a higher height, it's gaining gravitational potential energy, right?
Uh-huh.
So, and that's dependent on height, right?
Yeah.
So, gravitational potential energy is mgh, okay? And
Yes.
if you're taking this parcel that's on the ground and you're
Mhm.
lifting it up 1 meter, right? It gains gravitational potential energy, right?
Right.
So we can say that the work here is mg, which we know is going to be the 1,000 newtons, right?
Mm-hmm.
Times the height, which is 1 meter. And this would just be 1,000 Newton meters, which is the same thing as 1,000 joules, right?
Right.
Okay. Now that's the work, that's the energy that's required to move this box up 1 meter in height, right? Now, when we're dealing with machines like this, like a ramp is an inclined plane is an example of a simple machine. Now, you can't change the work, aka the energy, that can't change. But since we know that work is also FD, I mean, there's the cosine theta part, but if it's parallel, we can just say FD, right? If we if that work stays the same, what we could do is we can increase the distance aspect of it, which means that we would decrease the force aspect of it to achieve that same level of energy or work, right?
Yeah.
So initially, the distance was 1 meter, and the force that you need to apply to pull that package up 1 meter is 1,000 newtons. But if you have this ramp, this inclined plane that has a length of 5 meters, right? It would be F times the 5 meters equals, the 1,000 Newton meter
Joules. Oh, newtons.
or joules, yeah. And if we now solve for the force that you must apply, you would
It's
divide.
200.
Yep,
And you would get newtons left over.
yep. So what a machine enables us to do is
Is apply less force in order to do.
the same amount of work. Yeah. And so that's something that you can also see expressed as something called mechanical advantage. And that's going to be the ratio of, let's say, um, force output over force input, or distance input over distance output.
Okay.
So what that means is, so like the force output, right, would be the 1,000 newtons, right?
Yeah.
And the force input, what would that be? Like the force that
The
you,
200 newtons.
yep.
Okay.
And so this
And
would
distance
be,
input, do you, the distance input is 1 meter?
so now the distance input that we're doing is 5 meters,
5 meters instead of 1 meter.
and then
So
the
it's
distance
increasing the distance to lower the
is 1 meter.
force.
So this would be 5, right? And so this means that when you use this inclined plane, the force that you apply gets multiplied by a factor of 5, making it so you can do, like, you only have to input 1/5 of that force to get the end result to be like multiplied by 5. So you don't have to put in as much force to move this parcel here. If you just lifted it up this way, you would have needed to put in 5 times the amount of force than if you just pushed it up this incline.
Okay.
So you have a mechanical advantage here. And so inclined plane is one type of simple machine like this. There's also like the lever. There's also like a pulley.
Holy-
There's also like a hydraulic press. There's also, I think those are the ones that I can think of right now. But yeah, this is the topic of machines, and the entire idea of a machine is you're not changing the work, you're not changing the energy, but if work is FD, if you raise the D, the F that you must input goes down, and that gives you an advantage.
Yeah, can I try to explain this back to you what we did here? So we started off by like figuring out that like the distance is 1 meter. So we were like just on the regular system here. And if you had to lift it up all the way, then you would have to apply the full 1,000 newtons of force. And then we figured out that if you use the, I don't know what it's called, a ramp, you end up doing less force because you're increasing the using less force because you're increasing the distance. So we divided the 1,000 newtons by the 5 meters since it's in newtons per meter.
Oh, just Newton meters, like you multiply them.
Yes. And so the like 5 meters canceled out the other meters, and you ended up with 200 newtons of force for when you're using the lever ramp,
Mm-hmm. Yeah.
right?
So what so like the way to do this type of problem is first you determine the work or the energy, right? And we determine that to be, it's a gravitational it's a gravitational potential energy of 1,000 Newton meters or 1,000 joules, and that doesn't change. But when we set it equal to FD, like the work equation,
Mhm.
and we have that new distance from the ramp, that new distance is larger. And since the work has to stay the same, the force must go down by the same amount that the distance goes up. So that means
I
that,
understand.
yeah. So first you want to establish what that energy or that work is, and that does not change. But then since work is equal to force times distance, you can increase the distance. That means the force that you must input goes down. Okay.
I have like since I opened Notability at the start of the lesson, I've been like writing in
Mhm.
like little things
Yep.
for myself.
Mhm.
Okay. When an archer draws a bow. Okay, so this is elastic potential energy. So this is distance is 0.1 meter. Can I like newtons? Okay. What is the maximum height it'll reach before it falls down?
Mhm.
If gravitational potential energy is mgh,
Mhm.
this one wouldn't be considering gravity, right?
Uh, Tell me what you mean.
Well, potential energy takes into consideration like as the object is in free fall, it'll be like gaining acceleration due to gravity, and that's why it's gaining potential energy. But kinetic energy, the like lower it goes, the less kinetic energy it has.
Um,
Or no, the opposite is true.
so So okay, so we have this archer that draws a bow by that much, and then with an average force of that much, and it's stored as this elastic potential energy. Um, so we can calculate that amount of potential energy. I mean, this question isn't my favorite just because there's like a separate equation for elastic potential energy, but this problem kind of ignores that and just has you use like the typical work formula. So you have an F, you have a D, so that lets you calculate that work done to draw that bow, right?
Mhm.
Draw that bow. And so the energy is stored in that bow. And
But like what you pulled back, but isn't that potential energy, not kinetic, because you haven't released it yet?
correct.
Okay.
So, but yeah, when you do release it, it
Where
can,
am I getting the kinetic energy? It said that, right?
well, let's just see, like, let's just think about it like
Oh.
conceptually here. So we store that energy in that bow, and when the guy lets go of the bow, that elastic potential energy gets converted into kinetic energy, right? Because now that arrow is moving,
Hmm.
right? And as that arrow continues to move upwards, right, it's going to be gaining gravitational potential energy because it's gaining a height. Anytime you see a gain in height, you're gaining gravitational potential energy. Now, when the person releases that, arrow, that elastic potential energy gets converted into kinetic energy as the arrow leaves. And as the arrow moves upwards, since the gravitational acceleration is pulling it downwards, that initial kinetic energy, like the second it leaves the bow, is at a maximum. And as it moves upwards, it keeps going down because it's getting converted into gravitational potential energy as it gains height. So what we can do here is from that initial elastic potential energy that they give us, we can calculate that energy, and then that'll be conserved and converted into kinetic right as it leaves the bow. But as it continues to move upwards, right, it will have its kinetic energy converted into potential, gravitational potential, and that will enable us to figure out how high it goes ultimately before it then falls back down.
So how do you calculate that? You have to multiply the distance of the bow. That's the
So
way.
so first we can do like the
So, like, I'm noticing that, like, last time we had Newton meters and we have, like, both of those units, which I know you say to do sometimes, like, where, like, you're not sure which equation to use, but, like, you recognize values. Like, should I be doing that? Is it 0.1 times 300?
yeah,
That's what, like, what converts to joules, right?
yep. So like the work being done here would be the 300 newtons times the 0.1 meters, which would
Is
just
that something that we need to calculate the work done? Right? It is, because
wait, sorry, what was
then we have, well, then is, I was just wondering if work is a value that we needed to calculate here, because then we have 30 joules and then we have the distance. Oh no, we have mass.
yeah, so you want to, so what's
Looking.
this
Do we
question?
use MGH?
So what this question's asking is really conservation of energy. So this gives us that initial elastic potential energy that then gets converted the second it leaves the bow, the second the arrow leaves the bow, all of that elastic potential energy gets converted into kinetic. And then as it travels upwards, that kinetic energy gets converted into gravitational potential. And so what we're really doing here is we're doing conservation of energy.
Okay, for gravitational potential energy.
Yeah, so from this calculation here, we get, 30 Newton meters or 30 joules,
Mhm.
right? And yes,
And we have the force, so we can just find the distance without doing that math, right? With the mass of the object, right?
so now the
Or
second,
just force times distance, and we know that the work is 300 newtons, and that wait.
so
Yeah.
the second the arrow leaves the bow, all of this 30 joules that's stored gets converted into that kinetic energy.
Mhm.
And then it will, as the arrow moves upwards, that kinetic energy will be converted into gravitational potential energy, right? And that will be until it reaches its maximum height, right? Which is what they're asking for. So we can set this equal now to mgh, the gravitational potential energy, and divide both sides by mg, and you'd get h is equal to 30 joules or Newton meters divided by 0.2 kilograms, right? Which would then be 30 divided by, I guess you could do 2e negative 1 to get
Mhm.
15 e, or rather
Meters. Wait.
0.2 2e negative 1.
These E's just get confusing.
Oh, yeah. You
You
want,
always do that.
oh, no, just an
The
easy.
30, the 0, doesn't that just end up being 0 or 1? Yeah,
Uh,
10,
yeah, yeah.
80.
So, I mean, if you wanted to do the 0.2, we can do that. Um, so I guess you can leave it
Uh,
up. But yeah, this should give you the 15 value. Oh, I forgot. I see what I did wrong. I forgot to multiply it by g. So it's a 30 Newton meters times the 10 Newton per kilogram, which gives us the 300 part up here divided by the point
meters.
2 here, and then that should be 15. Like I would really do it like this. Rather,
Am I completely losing my mind? Or is 15 not half of 30? Isn't 30 over 0.5 15?
so the 0.2 we can turn into 2e negative 1, and then we can just say 2 goes into 300 150 times, and then 0
Oh,
minus
okay.
1 would be 1, or rather, sorry, 0.
E to the negative 1.
Yeah,
Then it's 15.
yeah. So the key thing here is just that energy is conserved, and so that initial distance and force that they give us, we can use to calculate the elastic potential energy. And we know that once it leaves the bow, it'll be converted into kinetic, and then once it reaches its maximum height, that's when all of that kinetic is converted into gravitational potential.
Okay.
So conservation of energy.
This one I understand. So gravitational potential energy over time.
Let's see. Electric motor is used to lift a mass M off the ground to a certain height. So we're lifting something upwards to a height means automatically that there's going to be an increase in gravitational potential energy, right?
Mm-hmm.
And then it says it does so in a time t. And then it asks what's the power, and power is energy over time or change in energy over time. And so the energy is mgh, gravitational potential, and you divide it by time to get power.
Okay, that makes sense. So because it's being lifted up, then the gravity has to be a factor always.
Yeah, if you're lifting something from one height to another height, you're changing that gravitational potential energy, which is,
There was no circumstance, like if it was pushed, it would be a completely different equation, right? So it would never be like MH
we say push.
over.
What do you mean?
Like I don't know, when you're saying like you're lifting something or putting something down, it would be MGH. So there would be no circumstance under which it would be B, where it's just the MH without the gravity. Like if the object is like being pushed sideways or something, like no lifting up and down,
Yeah, because you're not changing
then it's a completely
that
different
height,
equation. Okay.
that height part.
Yeah, I understand. Okay. I remember the thing with this because it couldn't be the object, like the person moving closer to the pivot. It had to be the load moving towards the left so that like the distribution was decreasing.
So this is all about torque here now.
Yeah.
We know that torque is this basically. The sine theta just means it should be perpendicular. The force should be perpendicular to the R. But
Hmm.
we want to see that there's two torques here. There's one torque of the person that the person's creating, and there's another torque that the load is creating. And
Hmm.
if we want to lift that heavy
The
load,
pivot and the load, the smaller it is, the easier it is to lift the load.
what are you saying?
The distance between the pivot and the load, the torque between them would be lower, so that would make it easier for the person to lift the object. But then if like the pivot moved towards the objects instead of vice versa, it wouldn't do the same thing, right?
So just think about it as two different torques, right? So this could be the R here, and this is the F for this torque between the pivot and where the person's pressing against it here. And then between the pivot and where this object is would be the torque of that load. And so, in order for this person to, it's another kind of simple machine question where they are asking us essentially to, like, what can be done to lift that load, meaning that the energy of lifting it is staying the same, the work of it being lifted is the same. But if we change something to make it so that the force that must be applied would be smaller, we would have to change this r distance between the person where the person's applying the force and the pivot, right? So if we look at, we essentially want the torque of the person larger than the torque of that load. So if you look at these choices, move himself closer to the pivot. If this person was closer to the pivot, like let's say here, right? That's going to reduce the R. And if you reduce that R, you're reducing that torque. So we don't want.
So lower torque means more like force applied.
Well, yeah.
Force would
In this case, we're comparing the torque of that the person's producing to the torque that the object is producing simply by having a weight. So yeah, if he moves himself closer to the pivot, R decreases, right? Which means that the force would have to increase if we keep that same torque. So we don't want that. If you move the pivot to the left, let's say the pivot's here, you're increasing the distance of the load to the pivot, which means you're increasing the R or torque of the load, which you don't want either. And then if you move the pivot and the heavy load to the left by the same amount, you're still increasing that torque for that load. So the only thing that involves us increasing the torque that this person is producing,
moving
increasing the R, would be if you move that
decreasing the R between the pivot and the load.
Yeah, or yeah, so we want to either decrease the distance between the load and the pivot or increase the distance between the person and the pivot. So if you move the heavy load to the left, where let's say it's over here, we're decreasing that distance between the load and the pivot, making that a smaller torque than the torque created by that person.
Okay. Do we need to stop?
Mm-hmm. Yeah. So I would let's see.
Exam.
Yeah. So
Listen, I'm really gonna try my best to get it all done today, but if I'm like passing out at the end by psych and so should rather take it tomorrow morning.
yeah, take it tomorrow then. Whatever lets you take it in one sitting. Um, and I guess for today you can just kind of like review the equations, review the.
No, I'm definitely gonna start the exam now, like to take
No,
the
we want to take it in one sitting.
I have class tomorrow. I can't do that.
That's why the weekend would have been best.
Okay, great.
You
All
don't need
right,
that.
I'll take the whole thing right now.
So
Sounds good.
like we want you to take it in one sitting. So when can you?
Yeah, I know. I'll sit down right now to take it.
Okay, but you're saying that if you don't get up to.
Well, yeah, I was saying that like the way that Blueprint let me take it in sections, I was like, I don't know, that's what we had discussed with my mom, but if you're saying you want me to take the whole thing today, I'll do it.
Yeah, because the actual test isn't in sections.
I know.
So we want to mimic that. That's why like the weekends were the best for that. But yeah, I would say that either take it tomorrow or take it on some day where you're able to take it in one sitting.
That won't be until the weekend. If I like will put it off until like it's a convenient time to start. My class load this semester is insane. I have 5 classes and I'm TAing 2 and I'm doing a thesis, so
Yeah. So again, that's why the weekend.
yeah,
But
I know. I'll take it tonight. Yeah.
but
All
are you
right.
gonna be able to complete it tonight?
Yeah, I'll do everything.
Okay. So all
All
right.
right.
Good luck.
And then I'll see you tomorrow.
All right, take care.